Solve our first question. So x of n is equal to sine omega naught n u of n. Okay. So how we can write this sine function? Can we write this as e to the power j omega naught n minus e to the power minus j omega naught n divided by 2j into u of n. Okay, so let's find the z transformation of these two signals separately. Okay, so first is e to the power j omega naught n u of n. So z transformation of this one will be 1 by, this is nothing but e to the power e to the power n u of n, right? So this will be 1 by 1 minus e to the power j omega naught z to the power minus 1. Okay, this is same as a to the power n u of n. So what is the z transformation of a to the power n u of n? That is 1 by 1 minus a z inverse, right? So we use the same property here, 1 by 1 minus e to the power j omega naught z inverse. Now what will be the ROC? That should be greater than e to the power j omega naught, or we can tell it is greater than 1, because mod of this one is, will be 1. Now e to the power minus j omega naught n u of n. So z transformation of this one will be 1 by 1 minus e to the power minus j omega naught n z to the power minus 1, and ROC will be mod of z should be greater than e to the power minus z, and ROC will be greater than e to the power j omega naught, minus j omega naught, or we can tell mod of z should be greater than 1, because mod of e to the power j, this is imaginary, right? So mod of this one will be equal to 1. Now they have common ROC, right? So the common ROC will be, they have common ROC, so we can tell that ROC of this signal will be mod of z should be greater than 1. Now sine omega naught n u of n. So z transformation of this one will be 1 by 2j 1 by 1 minus e to the power j omega naught z to the power minus 1 minus 1 by 1 minus e to the power minus j omega naught z to the power minus 1. Okay, so यहाँ पे हमें ये values मिला, just put this value here. Okay, and ROC, we have common ROC, right? So mod of z should be greater than 1. Now let's solve this equation. So I write this as 1 by 2j and this will be 1 minus e to the power minus j omega naught z inverse minus 1 plus e to the power j omega naught z inverse, and in denominator we will get 1 plus z to the power minus 2 minus 2 e to the power j omega naught z inverse minus e to the power minus j omega naught z inverse. Okay, now 1 by 2j, these two will get cancelled, right? Minus 1 plus 1, and we will take z inverse as a common. So z inverse e to the power j omega naught plus, sorry, this will be minus e to the power minus j omega naught, and in denominator we will get 1 minus, let's write this equation as e to the power j omega naught z inverse, or I take z inverse as common, plus e to the power minus j omega naught divided by 2 and multiplied by 2 plus z to the power minus 2. Now we all know that sine omega naught is e to the power j omega naught minus e to the power minus j omega naught divided by 2j, and cos omega naught is equal to e to the power j omega naught plus e to the power minus j omega naught divided by 2. Just place this value in this equation. So what we will get? Finally we will get sine omega naught n. So z transformation of sine omega naught n u of n will be z inverse e to the power j omega naught minus e to the power minus j omega naught divided by 2j will give you sine omega naught divided by 1 minus 2z inverse, this will be cos omega naught, right? So cos omega naught plus z to the power minus 2, and what will be ROC? ROC should be greater than 1. ROC should be greater than 1. Now use the property of scaling and find z transformation of a to the power n sine omega naught n u of n. So what will be the z transformation of this one? Use the property of scaling. So we know z transformation of this one is this. Okay, so a to the power n u of n, z transformation of this one will be nothing but if I write x of n. Okay, so z transformation of a to the power n x of n is nothing but x a inverse z, right? So instead of this we need to put a inverse z. Okay, so instead of z use a inverse z. So what will be the z transformation of this one? So this will be, instead of this, use a inverse z. Okay, so what is inverse of a inverse z? That will be a z inverse, right? So directly you can write here a z inverse sine omega naught divided by 1 minus 2 a z inverse cos omega naught plus z a square z to the power minus 2, a square into z to the power minus 2. And what about ROC? In this case ROC will be greater than a, right? So this should be greater than a. Now similarly we will find z transformation of cos omega naught n into u of n. So we can write this equation as 1 by 2 e to the power j omega naught n plus e to the power minus j omega naught n u of n, right? So find the Z transformation of these two signals separately. We have already found this, right? See here. So Z transformation of e to the power j omega naught n u of n is 1 by 1 minus e to the power j omega naught into Z inverse. Okay, so just put this value here. You will get Z transformation of cos omega naught n u of n will be 1 by 2 Z transformation of e to the power j omega naught n u of n, that is 1 by 1 minus e to the power j omega naught Z inverse plus 1 by 1 minus e to the power minus j omega naught Z inverse. Okay, now just solve this equation. You will get 1 minus Z inverse cos omega naught divided by 1 minus 2Z inverse cos omega naught plus Z to the power minus 2, and ROC will be greater than 1. And similarly, if you find the Z transformation of a to the power n u of cos of omega naught n u of n, so instead of Z inverse put a Z inverse. So this will be 1 minus a Z inverse cos omega naught divided by 1 minus 2 a Z inverse cos omega naught plus a square Z to the power minus 2, and mod Z should be greater than a. Now this is our next question. In this question, first one is x of n is 1, 2, 3, 4, okay, and 0 is at this position. So this will be 1, 2, 3, and this is 0. Okay. Now this is the right sided signal and we need to find the ROC. Okay, so this is actually right sided sequence. So in this case the ROC will be entire Z plane except at Z is equal to 0. Okay. Now in the next question 0 is present at this position, right? So ROC will be, in this case ROC will be entire Z plane except Z is equal to infinity. This is the left sided sequence, right? So ROC will be entire Z plane except at Z is equal to infinity. Okay, so in this case your ROC will be less than infinity, and in this case your ROC greater than 0. Now in the third case this is two-sided signal, right? Because 0 is at this position, so this is two-sided signal. So this is actually a two-sided sequence. So in this case your ROC will be entire Z plane except at Z is equal to 0 and Z is equal to infinity. Entire Z plane except z is equal to 0 and z is equal to infinity. So this will be your ROC. Now let's move to our next question. So here we need to find ROC of these signals. So first one is x of n is equal to 1 by 2 to the power n u of n plus 1 by 3 to the power n u of n. So what will be the ROC of this one? This is u of n. So this is right sided signal, right? So obviously mod z should be greater than, okay, should be greater than a. This is in the function of a to the power n x of n, right? So your ROC should be greater than a, mod a. Now this here value of a is, now here value of a is 1 by 2, so this will be greater than 1 by 2, okay, and here your ROC should be greater than 1 by 3. Now what will be the common ROC for this signal? See, 1 by 3 will lie somewhere here, okay, and 1 by 2 will be here, and this is your 1. So in first case ROC is greater than 1 by 2, okay, and in second case ROC is greater than 1 by 3. So this is your common ROC, right? This is your common ROC after this 1 by 2. So the common ROC will be the ROC of this signal. Now in the next question, the ROC should be greater than 1 by 2, okay, since this is a n minus 10. So in this case ROC will be entire z plane except z is equal to 0, what we have seen in the delta term. If delta n minus 1, we will mention that ROC is entire z plane except z is equal to 0. So in this ROC is entire z plane after 1 by 2. Now in this case what will be the ROC? See, for first case this should be ROC should be greater than 1 by 2, and in the next case also your ROC should be greater than 1 by 2, because this is not minus n, okay. If it is minus n, you need to mention that ROC is less than 1 by 2. So we can tell that overall ROC should be greater than 1 by 2. So if you get confused in this one, just remember that for right sided signal we always use z is greater than, and for left sided signal we use z is less than, okay. Now let's solve few question. Just take an example of this question, okay. Now find the ROC of or find the Z transformation, find Z transformation and ROC of what was the question? 1 by 2 to the power n u of n plus 1 by 3 to the power n u of n, okay. So what will be the Z transformation of this signal? This should be 1 divided by 1 minus a Z inverse, so 1 by 2 Z inverse. And what will be the ROC? ROC should be greater than 1 by 2, because this is right sided signal u of n. Now what about this? So Z transformation of this one, this will be 1 by 1 minus a, that is 1 by 3 Z inverse. What will be ROC? Since this is u of n right sided signal, ROC will be greater than 1 by 3, okay. Now just draw this one. if this is unit circle, now ROC is greater than 1 by 3. If this is 1 by 3, so ROC will be greater than 1 by 3. So this will be your ROC, right, is greater than 1 by 3. Now what about this? ROC is greater than 1 by 2. So this will be your 1 by 2. So this is the circle and ROC is greater than this. So your ROC should be greater than 1 by 2, right? So which one will be your common ROC? Let me draw it again. Now this is your unit circle. And for first signal ROC is greater than 1 by 3. So this is 1 by 3 suppose. And for this ROC is greater than 1 by 2. Okay. So for first signal ROC is greater than 1 by 3, and for second signal ROC is greater than 1 by 2, right? So which one will be your common ROC? This should be your common ROC, right? Greater than 1 by 2, right? This will be your common ROC. So common ROC will be the ROC of this entire signal. So common ROC is mod Z is greater than 1 by 2. Now Z transformation of this signal will be 1 by 1 minus 1 by 3 Z inverse plus 1 by 1 minus 1 by 2 Z inverse, and your ROC should be greater than 1 by 2. Okay. Now let's move to our next question. Now this is our next question. Consider a signal x of n is equal to 1 from 0 to 3, and in rest of the position it will be 0, and g of n is the function of x of n, that is x of n minus x of n minus 1. We need to find the Z transformation of g of n with ROC. Now let me draw Let me draw x of n first. Okay. Now this is our x of n. So x of n is 1 from 0 to 3. Okay, and we need to find g of n, right? So this is x of n. What will be g of n? G of n is x of n minus x of n minus 1. So let me draw x of or minus x of n minus 1. Okay, so how to draw this? So x of n is 1, so x of n minus 1 will shift the signal in right side direction by 1, and your amplitude will get reversed, right? So this will be minus 1 minus 1 minus 1, and this will be minus 1. Okay, now this is your x of n, sorry, x of n minus 1. Now we need to subtract these two signal, or we can tell we need to add these two signal. See, this is 1 and this is 0, so 1 minus 0 is 1. We will get one single at this point, and this is 1 and this is minus 1, so this 2 will get cancelled. Okay, this is also this will also get cancelled, and you will get minus 1 at this position, at the fourth position. So can we write this signal as delta n minus delta n minus 4, right? So this is 0 and this is minus. Now what will be the z transformation of this one? This will be 1. Z transformation of delta n is 1, and z transformation of delta n minus 4 is z to the power minus 4. Now what will be the ROC? ROC should be entire z plane except z is equal to 0. Now in this question we need to find the inverse z transformation of 1 by z minus 3. So we all know what is the z transformation of a u of n, a to the power n u of n. So for this z transformation is 1 by 1 minus a z inverse, right? So we can write this as z by z minus a. Okay, so we need to convert this equation in this form. So y of z can be written as z inverse into z, so that this 2z will get cancelled and you will get 1 in the numerator part. This will be z minus 3. Okay, बस यहाँ पे z इन्वर्स से मल्टीप्लाई करो, z से z इन्वर्स को मल्टीप्लाई कर दो, so you will get the same value. Now can we write this equation as z inverse z by z minus 3, right? So if you do inverse Laplace transformation of this signal, so what will be the inverse Laplace transformation of this signal? Sorry, I am telling Laplace transformation. So first we will do the inverse z transformation of this signal. So inverse z transformation of this signal is nothing but, instead of a to the power n, the value of a is here 3, so 3 to the power n into u of n. Okay, and when we multiply with z inverse z to the power minus n, when we need to shift the signal, see, if x of n, z transformation of x of n is x of z, then x of n minus n naught, z transformation of x of n minus n naught will be z to the power minus n naught x of z, right? So we need to do the time shifting. Now y of n will be equal to 3 to the power n minus 1 into u of n minus 1. What is the value of n naught here? That is 1. Okay, so you can use the property to find inverse z transformation of any signal. Now let's move to our next question. Now this is our next question. In this the pole 0. Now this is our next question. In this question the pole 0 plot is shown in the figure. We need to find the z transformation of y of n is equal to 1 by 2 to the power n x of n. So this is the pole 0 plot, and we need to find x of z from this. First we need to write equation x of z from this graph. So we have pole at 1 by 2 and zeros at plus j and minus j. So in the numerator part we need to place zeros, and in the denominator part we need to place poles of the equation. So where are zeros? So now 0 is at 1j and minus 1j, so this will be z minus j, and for this we write z plus j, and in the denominator part pole is at 1 by 2, so this will be z minus 1 by 2. Okay, we can write this equation as z square plus 1 by z minus 1 by 2, right? Now ROC of this one should be greater than 1 by 2. Y of n is equal to 1 by 2 to the power n into x of n. So y of n is equal to 1 by 2 to the power n x of n. Now what about y of z? So y of z should be equal to y of z is equal to z transformation of y of n is equal to nothing but, what is the z transformation of this? Suppose z transformation of x of n is x of z. So what is the z transformation of a to the power n x of n? That will be z by a, right? So z transformation of y of n will be x of z by 1 by 2. Okay, because the value of a is 1 by 2 here. Now apply now this will be equal to x 2z, and what about y of z? Just put the value of xz here. So instead of z we need to use 2z, so this will be 2z square plus 1 divided by 2z minus 1 by 2. Okay, so what about ROC in this case? So your ROC will get multiplied with mod a. Okay, so ROC was 1 by 2 and that will get multiplied with a value. So in this case ROC will be greater than 1 by 2 mod of 1 by 2 into 1 by 2. Okay.